Okay, so we're back. So I have asked you to examine the continuity, which means you need to talk about it, not just tell me if it's continuous or not. So whenever we use the word examine, be careful of that. So I want to examine the continuity when x equals -1. And I want to talk about that by looking at it and by thinking of these different conditions. So first of all, I'm looking at this and I'm hoping you're realizing that that is discontinuous. If I was the Silver Surfer, or if this was a roller coaster ride, we would go wee, ah, and you would fall down. That's not a good roller coaster ride, okay? And if you were going the other way, you'd be on here and you'd be going wee, and then somehow you would have to magically, without having any time change, go from this point to this point. And I really don't know how that happens without ripping all your atoms apart, right? Because there's absolutely no gap between where this line stops, because it keeps getting closer and closer and closer and closer and closer to -1. And there's absolutely, we get to -1, and then all of a sudden we have to be up there immediately. And so again, bad roller coaster ride, not fun to ride. So we have a discontinuous graph at this point. This is discontinuous at a point, and that point is x equals -1. Now that type of discontinuity, different books talk about it different ways, but most people refer to that as a gap discontinuity. You come down here and there is a, no, hold on, no, that is a jump discontinuity. I always get it goofed up. Most textbooks call that a jump discontinuity because you're coming down and then you jump over here and keep going. All right, so it's discontinued. Now tell me, which one of the conditions failed to get this discontinuity? Does the limit exist? Does the left-hand limit and the right-hand limit approach the same L value? The answer is no. It fails on the very first condition, doesn't it? So the limit as x approaches -1 of f of x does not exist. And the reason why it doesn't exist is because when I approach it from the left, so I approach from the left, I seem to be approaching, well, I don't know, I got to guesstimate what this is. Howbeit I call it 1.75. You can all either agree or disagree, and that's what I'm going to call it. And the limit as I approach from the right of f of x seems to be approaching 1. And last time I looked, 1 and 1.7.5 are not the same. So therefore, the limit as x approaches -1 from the left of f of x does not equal the limit as x approaches -1 from the right of f of x. And that is by definition a situation where the limit, the two-sided limit, does not exist. So yeah, I've done a lot of work in here, haven't I? And I've shown a lot of things. You should get used to that too. A simple answer of no there, or just discontinuous there, is probably a bad thing. My studio audience is squinting at me, so I think I need to make that a little bit bigger for them. So there you go. Copy that down. If you're at home, you get to pause the video. I'm always torn at this point whether I just sit and wait or stop the video, so I think I'll just sit and wait this time. Those of you that are done, you can start thinking about x equals 0. What about the continuity at x equals 0? Well, x equals 0 might throw you off a little bit simply because nothing special seems to be happening there. Like there's no holes, there's no jumps. Why would Mr. White ask me to look at the continuity at x equals 0? Well, because it's continuous at x equals 0. Once again, nothing interesting is happening there. It's a nice continuous graph. So we're going to say that f of x is continuous at x equals 0. And notice I'm having to talk about where it's continuous at a point. This whole section is continuous or discontinuous at a point. Later we're going to talk about intervals where we're going to put a bunch of points together. So we're looking at this and it's continuous at x equals 0, which means that everything must be good. Let's take a look. Does the left-hand limit and the right-hand limit exist? Well, yeah, it does. As I approach from the right, I'm approaching 1.5. As I approach from the left, I'm approaching 1.5. That's the same value. So my two-handed limit, or I keep calling it that, my two-sided limit, there's no such thing as a two-handed limit, okay? That's like a limit that you got to hold on with two hands. I don't understand. So my two-sided limit exists, and it equals, what did I call it? I think I called it 1.75 or something. And then, so they're going to the same value. And then f of 0 is defined, first of all. There's a point for it. And thirdly, those 2 points are equal. So, yay! We get the limit as x approaches 0 of f of x does exist. And I think I decided it equaled 1.75. And f of 0 is defined, and it equals 1.75. And therefore, they equal each other. So therefore, continuous. And that's the way that plays out. So then the last one that I want to look at is x equals 1. And that's kind of interesting. I'm going to be here now. Looking at this, if I had my little roller coaster guy, whee, ah, oh, that's a bad roller coaster ride, guys. That's really going to hurt. Look, whee, ah, oh, don't do that, okay? So that's definitely discontinuous. And this is called a gap discontinuity. I don't know why it's not called a jump, but it's not. This is a jump. If you go from one line to another line, it's called a jump. But apparently if you have to jump twice, we call it a gap. So this is called a gap discontinuity. Okay? And what actually fell apart on this gap discontinuity? Which one of the conditions actually fell apart here? Well, does the limit exist at that point? Does the two-sided limit exist? And the answer is yeah, it does. As I approach from the left and I approach from the right, I'm approaching the same value. So the limit as x approaches 1 of f of x does exist. It definitely exists. Is f of 1 defined? Well, yeah, f of 1 is defined. It's defined. And those are the essence of the first two conditions. Do both sides exist? Do both sides have a value? And the answer is yeah, they do have a value. Notice that the first two conditions don't give a darn what the value is. They just care, is there a value? Well, yeah, there is a value. But what's happening here is that the value associated with the two-sided limit is, what do you want to call that, 0.5? And the value associated with the function at that point is 2. And so the problem here is that they don't match up. And that violates condition number 3, doesn't it? And that is going to give us what we call a gap discontinuity. So there's different types of discontinuity. We haven't even seen them all yet. There's also asymptotic discontinuity, where we're going to a vertical asymptote on either side. But this is the basic idea of conditions for continuity. And I must tell you, this one doesn't give a darn about a value. It just cares, does the left-hand side equal the right-hand side for the limit? This one doesn't care about a value. It just cares, is it defined? Now is the only time I start to care about the values. Now, do the values equal each other? Now I'm interested in the values. Okay, I'm going to stop the video there, and I'll be back in a moment.